Along with our exponential and linear functions, we have something called arithmetic and geometric sequences. By the end of this lesson, you should be able to think reasonably to discover and continue a number pattern. You should be able to form arithmetic and geometric sequences, and then use their formulas to continue a pattern. So a sequence is just a number pattern, and it could be absolutely anything. Like you add could be positive or negative. So it could be getting bigger or it could be getting smaller. Like 1, 3, 5, 7. The common difference is the fixed number being added every single time. So in this example, our common difference was a positive 2. I added that every single time to get the next one. I want you guys to come up with a new arithmetic sequence and tell me what the common difference is. And now a geometric sequence is one formed by multiplying a fixed number to each previous term. So if we start with 2 and then we do 4 and then 8 and then 16, we can keep on going. But what I'm doing every time is I'm multiplying by 2. And that 2 this time is called a common ratio. So come up with one of your own. The biggest difference here that you need to remember is common difference is a number being added or subtracted. Common ratio is a number being multiplied. So let's find the common difference of each sequence. What we're asking ourselves is, what do I have to do to each number to get the next one? So to go from 11 to 23, I gotta add 12. And then double check that that works. If you do 23 plus 12, you definitely get 35. So the common difference is 12. Now the next one, you can see that these numbers go down, so our common difference is going to be something negative. So to go from 8 to 3, I got to subtract 5. From 3 to negative 2, I do the same thing. Then negative 2 to negative 7, do the same thing. So again, our common difference is negative 5. So this is a rule that allows us to figure out any number in the sequence without having to continue the pattern over and over again. And this is linear. We are adding or subtracting something over and over and over again. So this common difference right here tells us how to get to the next number. So now this is kind of confusing, but let's say we took a sequence like the 1, 3, 5, 7, 9, on and on and on. In order to figure out the next number in this pattern, you need to know the first term, so in this case that would be my A, and then the term number. So let's say we wanted to figure out the next term. We know what it is, but it would be our 1, 2, 3, 4, 5, 6th term. So we do plus 6 minus 1 times our common difference, and here we add 2 over and over and over again. So this ends up being 1 plus 5 times 2, or 11, which is what we knew that it was. So the thing you got to watch out for in this formula, and the reason why it's written this way, is you take into account the first term. And then this part right here, because we already used up the first term, we have to say this is the second term, this is the third term, this is the fourth term. But we multiply it by the common difference. So if we do n minus 1, 2 minus 1 gives us 1. So we multiplied it, or added the common difference, only once. Here we added the common difference twice. That's why we got to subtract 1. Here we added it 3 times. So we got to add, or subtract 1. So you will use this formula to find things like this. Find the first, 6th, and 12th terms of each sequence. So if I want to find the first term, that's when it's 1. So I do negative 5 plus n minus 1. So 1 minus 1 times 3. This ends up just being negative 5, because you get 0 times 3 here, which goes away. So my first term is negative 5. You could have seen that from just the equation also. 6th term, without having to write all the ones in between, all I got to do is plug this in. 6 minus 1 times 3. So you get negative 5 plus 5 times 3. Or 10. So remember, this means that you added 5, or that you added 3, sorry, 5 times. That's your common difference here. I want you guys to find all of them for that one. So geometric sequences are pretty much the same, except they have a common ratio. And remember, that means multiplication. So ask yourself, what do you have to multiply by 750 to get 150? 150 to get 30, 30 to get 6. Now hopefully you notice the numbers get smaller. So that means we're going to multiply it by a number less than 1. Now this is an easy one. I can do this in my head. It's 5. So then double check. 150 divided by 5 does give you 30. So that means I need to multiply it by 1/5 every single time. I start with something and I have 1/5 of it left over. So my common ratio is 1/5. Then this one, it grows, but it grows in negative land. So if I start with -3 to get to -6, all I gotta do is multiply by 2. And then -6 to -12, multiply by 2, same thing with this. So my common ratio is just 2.